Hi, everybody. This is Dr. Kathy Jones Trivitowski. I'm real excited to be with you in this class. We're going to talk a little bit today about normal distribution. How many of you, when you hear the words appraisal, assessments, statistics, psychometrics, kind of look like you might understand a little bit what's going on, and then as you get further and further along, you start questioning yourself until you're like this poor guy and you just want to hang yourself. Let's see if we can make things a little bit more easier for you. Well, let's talk about scales of measurement first. Many of you may already remember this from some previous math classes, but just a quick refresher. By the way, these types of, you'll need to know the definitions of these different types of scales of measurement, whether it's for this class or perhaps in your licensure. So nominal, N for naming, all right? That's a qualitative variable. So that's naming, listing. Examples would be gender, educational level. Ordinal, that means O for order. Ranked order, these are discrete variables. So kind of an example would be a Likert scale. So on a scale of 1 to 10, how much do you love being in this class with me? Hopefully a 10, which is the highest. We also have the interval scale. And this is a magnitude and equal intervals. An example would be temperature. Now the biggest difference between the interval and the ratio scale is the ratio scale has an absolute 0. Examples would be age, height, and weight. Our next slide is talking about measures of central tendency. And the following slides will talk more in detail about this. Just remember that it's a distribution of scores, a measurement of a number of individuals that can be examined using the following measures. The mode, the most frequent score in a distribution. The median, it's the middle score in a distribution of scores. And the mean is a arithmetic average, symbolized by an X, sometimes an X with a line over it, or the capital M. Just a side note, when you're taking this central tendencies and it appears in your licensure exam, you do not need to know the formulas for the National Consular Examination. But you will need to understand what these mean and the definitions. Here we have a slide on the mode. And as I mentioned before, the mode is the most frequent score within the distribution or within the set of the data frequency. So let's take a look at the bar graph. So let's take a look and say, all right, how often does a set of data show 5? Well, obviously 1. Well, how often does it come and show 3s? So we have 1, 2, 3s. All right, definitely more 3s than the 5s. Okay, let's take a look at the set of scores in the 2 range. 1, 2, 3, 4, 5, 6. All right, so maybe this is the most frequent set of data, much more than the other ones. The last set of data scores that we're going to look at are in the 1 frequency. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Definitely many more scores in the 1 range than any others. So the 1 would be would be the mode. All right, so when would we use the mode? Well, it's used mainly with the nominal scale data. Remember, that's with the naming. All right, and this is the only measure of central tendency that's appropriate for the nominal scale. Now, another measure of central tendency, as mentioned before, is the median. We've already talked about the mode. And the median is the middle score in the distribution of scores. As noted here, it's just another name for the 50th percentile. It's the score in the middle, smack in the middle. Half of the scores, therefore, are larger than the median, and the other half is smaller. So, when do we use that median for the central tendency? Well, that's when we often use it when scores are either positively or negatively skewed. And we're going to talk about that in just a moment, so you get to look at some graphs of what is positive. All right, that's when there's few really large scores. Or what does a graph look like when it's negatively skewed? And that's when there's really small scores. All right. Now let's talk about the last measure of central tendency, and that's the mean. Remember what I said earlier, that the mean is a arithmetic average symbolized usually by an X or an X with a line over it, or by the capital M. The mean is where you take all the scores and you add them all together and you divide it by that same number of scores. So let's say I'm adding 1 plus 2. I had a score of 1, I had a score of 2, and I had a score of 3, and I had a score of 4. All right, and if you add those all together, that equals 10. Now, because I have 1, 2, 3, 4 scores, I'm going to divide it by 4. So 10 divided by 4 would equal, of course I have to get out my calculator real quick. Equals 2.5. And therefore that would be the mean. It would be represented by the X, or the X with the line over it, or the M. All right, one of those three symbols, but let's say it's the X. X equals 2.5, and that would be the mean. Okay, and this slide gives you some more examples so you can actually see. So again, you have several different scores here. You have a 1, you have 5, 4, 3, and a score of 2. And you're going to add all those up, and that equals 15. And then you're going to take 15, you're going to divide it by the number of scores. So 1, 2, 3, 4, there's 5 different scores being represented here. So 15 divided by 5 equals 3. Therefore, your mean is X equals 3. Now, when do we use the mean? Well, guess what? You can use it with your interval and ratio scales. And many people, as noted in the slide here, also with the ordinal scale. The data are not skewed. Remember, before you had that skew to the right or the left, or positive or negative. This time it's not skewed. All right, the mean is preferred because it is sensitive to every score. If you change one score in the data, the mean will change. Now, what is the relationship between these different measures of central tendency? Something that you would need to remember is that for normal distributions, okay, you have the mean, the median, and the mode all equal. And when you have symmetrical distributions, you have the median and the mean are equal. Okay, we're going to talk for a few minutes in the next couple of slides. We're going to talk about the normal curve. Some people call it the bell curve, and I see that I've misspelled bell. It should be a double L, B-E-double-L. So that's a bell-shaped curve. The normal curve essentially distributes the scores, the individuals, into 6 equal parts, 3 above the mean and 3 below the mean. Counselors should be familiar with the distribution of scores within the normal curve. Basically, 34% and 34% equals 68%. This comprises one standard deviation. 13.5% plus 13.5% added to the 68% equals 95% and comprises 2 standard deviations. Last, 2% plus 2% plus the 95%, okay, equals 99% and comprises 3 standard deviations. And you can see that standard deviations here are shown as SD. All right, so minus or plus 1 standard deviation, and so on and so forth. So let's take a look at the bell curve. Okay, here is a slide of the normal curve or bell-shaped curve. You also have this in your Watson and Flamez textbook. Take a look at page 39. And as you can see, the mean is a smack dab in the middle. Okay, that's the line right in the middle there. And you have 1 standard deviation to the right of it, and you have 1 standard deviation to the left of it. Each standard deviation, the one to the right is 34%, and then to the left of it, 1 standard deviation is again 34%. You add those two together, that means 68%. 68% of the population falls within 1 standard deviation. Now, if we go for 2 standards of deviation, all right, from 1 standard deviation to 2 standards of deviation, that's 13.5 on either side. All right, so if you add those up along with the 68% of the first deviation, that comes out to be 95. 95% of the population. Then we have the very tail ends. Okay, see how skinny it's getting at each end, right? It almost looks like it's going down to nothing. This is the 3rd deviation on each of those little parts of the scale. If you go from the 2nd standard deviation or the 2nd SD and you go to the 3rd SD, that's 2%. So you have 2% on the right and 2% on the left for a total of 4%. You add that to the 95% and you'll have 99% or more of the population. So I'm spending some time in really trying to get you to think about this 68%, the 95%, and 99%. This is going to be, in your exam, whether it's within this class or for your licensure, and when you're thinking about standard deviation. So this is just another slide, just trying to reinforce it. Well, understanding the standard deviation is one thing, but putting it into practice is another. Why is this so important to you? This is how you're going to be scoring things and understanding what the scores mean of the different assessments, the formalized, standardized assessments that you'll be giving. Some of them you're going to be scoring as percentiles. And something that you're going to learn more about a little bit later on is something called the Z scores and T scores. Maybe the Stay 9, and maybe some other types of scores, but those are the more frequent ones. Now remember, the mean is right smack in the middle. That's the 50th percentile. And we talked about the 68, right, the 95, and the 99. But we also talk about the plus or minus standard deviation. So at the 68, remember, half of it is 34, one way or the other. So if you have a score of -1 standard deviation, you're going to take half of that 68, right? That equals 34, and you're going to subtract it from the 50, 50 being in the middle, right? That means you're at the 16th percentile. And as noted, if you have a +1 standard deviation, you're going to again take half of the 68, the 34, and you add it to the 50, and now you're at the 84th percentile. And so on and so forth with the second and the third deviations. So if you're at the third deviation, you're +3, right? So you're adding that to your other scores. You're going to be at the 99th percentile. Now let's talk about some of those skewed scales that I had mentioned way at the beginning. You have a skew is a degree to which a distribution of scores are not normally distributed. So they're no longer in that bell curve. To be positively skewed, that means the mean is greater than the median. All right? The mean is greater than the median. The positively skewed tail goes to the right. So it's like you have this large hump and it slopes down very dramatically to the right. Sometimes positively skewed is represented by a symbol that looks like a P and an O. So this is kind of what a positive skewed would look like. Notice it doesn't look at all like a bell-shaped curve. You have the hump, the highest point, to the left, and the tail goes down to the right. So as you look at the hump, the highest point will be the mode. The next highest point would be the median, and the lowest will be the mean. Whether it's positively or negatively skewed distributions, okay, the mean is pulled in the direction of the extreme scores, all right? So it's always going to be at the lower end, towards the tail. So now let's talk about the negatively skewed. Again, it will look nothing like the curve. Sometimes it's represented with the symbol NE. Just like the positively skewed scale, note that the mode is always going to be the top of the curve, both for the positive and for the negative. The next will be the median. The next highest point will be the median, just like the positive. However, here the mean, which again, remember, pulls the tail, is always going to be the smallest part. And this time the tail will be to the left, causing it to be the negative skewed scale. Okay, and so here I have a representation of what a negative skewed would look like. And again, you would see the top part would be the mode. As you come down to the left, the next highest point would be the median. And the next central tendency would be represented by the mean, which is way low. Again, the tail is pulling the mean. To the left will be negative. If the mean is pulled to the right, you guessed it, will be the positive skewed. All right, I hope you all had fun, and I hope that with all the additional information that's in your text, that you have a better understanding of this material. I'll see you next time.